Hello, in this video we would like to tell you a little bit more about how you can configure your storage connector to listen on port 443 and to do SSL termination. In a regular architecture, there is always a load balancer in front of your storage connectors. It has two roles. First, it will accept the traffic from your clients from the local area network or the internet and terminate the SSL traffic from port 443 and redirect it to port 9000 HTTP to your storage connectors. In some cases, it is required that the traffic between load balancer and storage connector is re-encrypted over SSL, and we will need to terminate the traffic on port 443 on the storage connector itself. In some cases there is no load balancer, and in that case we will need to do the SSL termination on the storage connector. Now it's always a best practice to have that load balancer because it needs to also divide the traffic on the available storage connectors. So what are the steps needed to do this? First of all, you need an SSL certificate. An SSL certificate is being generated starting from a private key from which we will generate an certificate signing request, a CSR file, and from that the provider will give you an SSL certificate. Now this step, private key and CSR, is not in the scope of this video, so we're going to assume that there is already a SSL certificate. We will generate a P12 and we will combine then that into a JKS file. We need that JKS file to run the Python command to configure the storage connector to listen to SSL. It will listen on port 9443, so we will also need to create a rule that will forward all incoming traffic from port 443 onto port 9443. And that is the last step. We will do that in IP tables. The first thing that I need to do in this system is log in with the user Syncp with the password on-prem, which is a default password. I'm then being asked to change that password, first by entering the current password on-prem and then choose a new password with numerics, alphanumerics, uppercase, lowercase, and preferred also special characters. I need to confirm that password, and when I've done that, I'm actually logged into the system. But because I'm going to do a lot with the root user, I'm going to change the password for root as well. I'm doing that with command sudo passwd root. I first need to enter that complex password for Syncp, and when I've done that, I can choose a new password for root. And the good thing is you can ignore all the warnings that it will give you. You can choose whatever password you'd like. And you can ignore all the warnings that it will give you. Just confirm the new password. Make sure you enter the password correctly. So do that again. Go and choose a new password. And again, it gives me a warning, but I can ignore that. I'm going to confirm it, and the password is changed. And actually, for my environment, I would rather have the password for Syncp being set to the default on-prem. So I'm going to change the password for Syncp to on-prem. I also want to change the keyboard for my environment, so quickly going to change that. The configuration file is stored in the folder /etc, and then open the vconsole.conf with vi. I'm going to change the keyboard layout to Belgian for my situation, but you will find all the other potential configurations on our documentation, and also Google is your friend here. Now I'm going to reboot the machine to make sure that the settings are applied. I can now log in with my favorite user Syncp, and I'm going to change to root. And what I'm going to do now is to make sure that this computer, this storage connector, listens to the network. I'm going to configure the network configuration file. I'll do that by navigating to /etc/sysconfig/network scripts. There you find the configuration file of the network interface card. And what I'll need to do is I will need to update DNS. I'm going to do that by removing the first line, and I'm going to update my DNS server to my situation. That is the IP address of my DNS server. I'm going to give this storage connector a fixed IP address which is 66. I'm going to specify a gateway, correct the broadcasting address to 255, and I'm going to disable IPv6 because I don't need it in my demo environment. When that is done, I can save the file and reboot the machine. In order to keep this video really focused on the point of configuring SSL, I have skipped a few things. So first, normally you would also have to create a storage vault in your Syncplicity admin console. We consider that for this demo you have already a working storage vault. So you have already obtained the access key from your admin console. You have mounted the storage in case of NFS, or you have configured the storage nodes if you use S3 or Atmos or something. So that means you have configured FSTab already, and you already made sure that your S3 storage works. Actually, you should have already configured the entire syncp-storage.conf file already, and we also assume that your storage connector listens already on port 9000 of its internal IP address. So let's continue with assuming that all the rest has already been done. If we started the storage connector, I can log in, and what I actually did as a preparation, I have copied the certificate and the key file to my storage connector. What I now need to do is check if the storage connector's certificate and key file belong to each other, and I will do that using these two commands to calculate the MD5. If these correspond to each other, then I'm sure that my certificate belongs to the original key file. I recommend this to always do this when you are chaining a key file and a certificate together. Next, we're going to convert those two into a P12 file. I will use the certificate, the key, in order to generate the P12 file. I need to enter a password for it and verify the password. And now I can check if the certificate is there. There you see the P12 file. Now I need to generate the Java Keystore file. In order to do that, I need to know where my Java is located. I can find that with the which Java command. It will give me the path. I will copy that in a text editor, and then I will combine that with the documentation in order to generate my key tool command. I will use this as the password for my Java Keystore file. That is the name of my Java Keystore file. I will generate that based on the P12 file that I created earlier in my temp folder. The source type is a pkcs file, and I will use also this password for this Keystore file. I will copy that command and I'll paste that in my Linux appliance, run the command, and you see that it now has successfully generated the Java Keystore file, and it added one entry alias. That was done successfully. I now have a JKS file, and I'll need to copy that into the save location for my certificates. So I'm going to copy my JKS file into the /etc/SSL/search folder. And when that is done, I also need to make sure that only root has editor rights and everyone else just has read rights. So I'll navigate to that folder, and I'm going to change the permission using 644 on my sc.jks. I can now do an ls-l to check the permissions on the file, and you'll see that only root has editor rights, all the rest has reader rights. For safety reasons, I'm also going to copy my key file, my key.pem, also to this location. And optionally, you can also change the permissions on that key file so that only root has editor rights on it. I can now run the Python command and enable the storage connector for SSL offloading. I will navigate to my syncp-storage folder, and I will run the Python command in which I reference my Java Keystore file and the password. When that is done, I need to restart the syncp storage service, and then I can check for the status, and it will show me that it is running. And now I can test if I can reach the storage connector. I'll first try this using the IP address, and you'll see that on port 9433 it will listen, It will complain that the certificate is not okay, but that's because I'm using the IP address. That's fine, I'm going to accept that. But when I try to do a curl on port 443, then you will notice that the connection is refused. And that is because we have not yet rerouted the incoming traffic on port 443 to port 9443. In order to do that, I'm going to use IP tables. IP tables allows me to add an additional rule, add a pre-routing rule, so that all traffic coming in on port 443 on the network interface ETH0 is going to be rerouted to port 9443. And when that is done, when I save the changes, I can now check this configuration in IP tables, and you'll see that now I have a pre-routing route. Actually, I have a double because I accidentally did this twice. But you also see that the other configuration rules, like only accept traffic on port 9000, is also applied here. And I can add an additional rule to accept also traffic on port 9443. This will allow the storage connector to also listen on port 9443. I can also remove now the double line that I accidentally added. I can save this and restart IP tables. You'll see that when I still do a regular ping on HTTPS, it won't work. And unfortunately, the port rerouting does not work on the storage connector itself. It only works on other machines. So what I will do is I open a browser. From the browser, I will first try to do a ping using the IP address and on port 9443. Just to check that everything works as it should. And despite the warning message about my SSL certificate, I get a pong back, so that works. Now let's try to do the same on port 443. Also get an SSL warning, but it means that IP tables is doing its work and it's rerouting the traffic from port 443 to 9443. Finally, I'm going to do a test with the fully qualified domain name of my storage vault. And if this works, which apparently it does, I get the green padlock icon and I can see that my SSL certificate is now being used to terminate the SSL traffic. So that's it. I have configured now my storage connector to listen on port 443, and that's what we'd like to show you in this video. I hope it was beneficial for you, and if it does, please subscribe. Bye.